Good morning, Advent of Code Day 8. Well, a lot of the time, just telling you how many lights are turned on will tell you the digit, won't it? 1 has 2 segments, 4 has 4 segments, and I expect part 2 is going to ask us which letter corresponds to which wire. I wonder why it's got a fixed... Oh, interestingly, in the first part of the line, there's always the same number of wires switched on. I don't recall seeing what the pipe symbol is for. So the bit after the pipe is the 4-digit output value. Counting only digits in the output values. How many times do digits 1, 4, 7 and 8 appear? It's a good job I reread that. How are we going to do this? Is this a scanf jobby or is this a character at a time jobby? I think character at a time. So what was it? A, B, C, D, E, F, G. So each go through the loop will read us one 7-segment display, and we want to know if we're on the output part. So we'll reset got to 0, reset on output to 0. When we say the pipe, we're on the output. If it's a digit, oh no, we want to reset got to 0 when we see a space. And in fact also at the start of the line. When we see a space, well, we don't need to do anything yet. When we see a space, the number is terminated, and when we see a new line, the number is terminated. Oh, hang on, I've confused myself there. When we see a new line, so we'll initialize got to 0, and on a new line, reset it to 0, set on output to 0. And on a new line, oh actually we only want to know how many 1s, 4s, 7s and 8s there are, so we'll just check number. Actually, we only need n got, don't we? Maybe we'll keep got for part 2. I don't think it'll have duplicate digits within a single number, but it doesn't hurt to check. Oh no, hang on. 2 or 3 or 4 or 7. Answer plus plus. Ugh, now I have to do the same thing. I don't have any copy and paste, else I would have either copy and pasted it or put it in a function. It was asking for the number of them that are 1, 4, 7 or 8, wasn't it? Not the sum of the values 1, 4, 7 or 8 or something. So when we see a digit, we increase the number of digits we've got. When we see a pipe, we know we're on the output stage. When we see a space, if we're on the output stage, then we know we've terminated a number and we check how many digits we've got. N got equals 0 here. When we see a new line, we reset everything. Yeah, we decided deleting lines from the end would be better. No, it doesn't work. Is this the sample input? So I want to join these. This is really tedious. I need a better way to delete lots of lines at once. I do have a way to ask for some commands in the editor to be repeated several times. So I can go 10J and it will move it down to 10 lines. But if I go 10 delete line, it still only does 1. I can hold it down and it will do several without redrawing the screen, but then I can't see what it's doing. Okay, that looks good. So there's 11 lines of sample input there. Did the problem statement say that the first one of those actually was part of the sample input? No. What does it say? Brilliant. Only if we're on output we want to do this. So that should have overcounted rather than undercounted. Oh, it's not digits, it's letters. That's the problem. The input was about 16K. So 26. Oh, the sample wasn't 16K, was it? Good. Yes. Add up all of the output values. Okay. Do 1, 4, 7 and 8. If we only look at the lines from 1, 4, 7 and 8, will that tell us everything? Well, there can't be any zeros because zeros are unrepresentable in the input. So 8 has 7 digits set. 5 has 5 digits. So do we need to keep track for each letter which segments it could possibly be? And when we see an input like DAB, we know DAB means 7, so every segment that isn't part of 7 can't possibly be A, B or D. And then once we've got to the pipe symbol, hopefully we'll know for every segment for every letter which there should only be one segment it can be. And if we have one left over, then that must be the remaining segment. So we want to say we want to keep track of what it can't be. Am I going to do a two-dimensional array? Or just a... Yeah, I think so. So we'll have... Don't forget your I++. Can't be. Needs to be set to 0 because we don't know that any of them can't be any. So on a new line, we need to set ingot equals 0, on output equals 0. Is there any other state we need to reset on a new line? Don't think so. So on new line, we'll go new line. Okay, so part of new line is actually new number. And on new number, we go ingot equals 0 and set got 0, 7. If we're not on the output, we want a new number. Otherwise, we want to try to work out what number this is and then do what with it? We needed to add up all the output values, didn't we? So this output is this output times 10 plus, what number are we on? And on a new line, and at the start we need to say we're on a new line. Reset the output to 0. Oh, and yeah. Oh, did we already have a var for answer? Yeah, so that doesn't. Number terminated, so we already do this stuff in new num. We want to go new num regardless. And new num, yeah, new num doesn't do any harm. New num does what we want. So, do I just need to implement what num? Then it'll work. So we know which segments we've got. Well, we can do the easy cases. If we've got 2, then the number is 1. If we've got 4, then the number is 4. If we've got 3, then the number is 7. If we've got 7, then the number is 8. Otherwise, we can have 5 or 6. If we've got 5, then it's either 2, 3, or 5. If we've got 6, then it's either 6 or 9. So we've got 1, 2, 3, 4, 5, 6, 7, 8, and 9 covered. Okay. So, we need to look at the segments we've got and rule out numbers based on what numbers it can't be. Am I setting can't be anywhere? No. New num needs to set can't be if on output. So if the number we've got is 2, then every so this function will mark can't be num except for the ones that are set in got. So if we haven't got this segment, then this segment can't be none. Similarly, if n got equals 4, mark can't be except got 4. If n got is 3, mark can't be except got 7. And if n got is 7, can't be except got 8. No, that's wrong. Can't be isn't telling us. Which number it can be. It should be telling us which segment it can be. This is quite complicated. So I'm going to call this a shorter name. So this is going to be called MCBE. And then these are going to go, it can't be except, and actually we won't take got as an argument. So which digits were set in 2? I'm going to write down these. So the segments that are set. Oh, we can have 0. 0 is a possible input. 0 has 6 segments set. So set in 0, we've got A, B, C, E, F, G. Set in 1, we've got C, F. Or cat problem, type Control S. For some reason Control S wasn't working on more. Right. I think it might be because more's outputs. Don't know why. 5, A, B, D, F, G. So if we've seen 2 digits, then we know the digits we've seen are C and F. So we need to mark can't be. Oh. For the ones we've got, for the ones we haven't got, we know that they can't be digits C and F, which are, if I just write down so that I don't mess it up, which are 2 and 5. So we want to mark can't be except 2, mark can't be except 5. And for 4, this feels like I could put these in an array instead of hard coding them, but we'll press on. So for 4, it's the number 4, so we need to mark B, C, D, F. That's 1, 2, 3, 5. Actually, if it's 7, then they're all set, so we can't mark anything. So then we can go, well, it can't be except 2, 5, and there are 2. This is 1, 2, 3, 5. Actually, we already know how many there are because it's n got, although we don't need to. Number 7 is ACF, which is 0, 2, 5. So we mark the segments that we haven't got as saying that they can't be the segments that we've said there. Okay, and then when we're asked what number it is, how would we know? If we've got 5 set, then it can be 2, 3, or 5. So we need to know if the segments that we've got can correspond to ACDEG, ACDFG, or ABDFG. So if it's 2, 3, or 5, we already know that A, D, and G must be set. So then we need to know, is it B or C? And is it E or F? If it's B, if B can be set, if it's B and F, then it's 6. If it's C and E, then it's 2. If it's C and F, then it's 3. So let's see. We don't need my can't be, do we? We can just look at it. Or do we? So this isn't can be, this is can have. What segments can we possibly have with the input we've got? So for each possible segment, if we've got that segment and are we asking if we've got that segment or if the segments we've got can't be that segment? Why am I finding this so difficult? Well, what do I want to write down here? If we might have I wonder if there's a distinction between might have and definitely have. Can we ever know we definitely have something? Well, we'll just go with might have so far. So if we might have B and we might have F, which means we might have 1, we might have 5, then we'll say it's a 6. if we might have 2 and we might have 4, then we'll say it's a 2. If we might have 2 and we might have 5, then we'll say it's a 3. Otherwise, now if 6 are set, what are the cases? 6 and 9. So then it's only a question of D or E. So if we can have D, then it's 9. If we can have E, then it's 6. Otherwise something's gone wrong. So can have wants to tell us which segments we can have. So let's say I is a segment, and we're trying to find out if we can have that segment. So we want do we start out assuming we can have it or assuming we can't have it? I think we start out assuming we can't have it, and if none of the segments we've read can't be it, then we can have it. So we want to know if none of them can't be it. So if any of them can't be it, then we can't have it. So when we go if can, then can have I equals 1. Here we'll go j equals 0, or j is not equal to 7. If we've got j and can't be, is it called can't be? ji, then can equals 0. Don't forget your j++. So can't be ji means the segment called j can't be the segment that's actually I. And are we resetting can't be on new line? Can't remember where that was. Yes, we are. Well, that might be it. Let's try that and see what happens. I feel like I've forgotten something. Oh, we need to free. Well, we won't free it. What we'll do is we'll just make it a global. And on new line, are we saying what output we've got? Yeah, okay. I think this problem is quite confusing because there are lots of different things that the numbers 1 to 7 can refer to. They can refer to the numbers that are actually displayed on the display, or the segment numbers of the real display, or the segment numbers we've been given, and you have to remember which one you're talking about each time. Maybe I'd have been better off making my arrays long enough that I don't have to turn the characters into numbers, because it's barely using any memory, so I could do that easily. Not that. Okay, let's put it on the sample input and see what it says. Legal sixth segment. Okay, interesting. We're 9869 and, well, 0 is probably wrong. Oh yeah, that's just when we're initializing. So the first one's 9869 and 9978. No. Should be 8394 followed by 9781 followed by 1197. And I'm surprised it got the 8 wrong, because 8 is what you get if you have 7 digits. So oh, I don't know what this bit said. Well, ah. B, CF, BE, GAD, CBD, GEF, FGA, ECD, ED, FD, CGE. It's possible that I made a typo here. I just want to see what it does. So the FDG ACBE should definitely show up as an 8. 9866, that is actually a different that's a different number to what it gave last time. No, I must have made a typo. Okay, well, there remains the problem that it thinks the first digit is a 9. Well, I don't need that actually. I'm wondering if something to do with the multiply is wrong, but that looks obviously correct. Yeah, it's saying 9869, what the hell? If ngot is 7, then we just return 8. So it's saying ngot isn't 7. So, where were we? So 9, 6, and 9 are all the else case. So if we say ngot equals 6, otherwise but why would ngot be wrong? On new num we should be resetting ngot to 0, shouldn't we? Which we are. And when are we increasing ngot? if we haven't got it already. Don't understand. I've just noticed that 0, 1, 2, 3 and 5 are the only segments that we ever mark can't be, which means we need to move the test for E. We need to not test for E because we never set can't be E. So everything thinks it can be E. So we need to just make that the default case. So my 6th segment decoding thing is wrong because based on what I've got written down on paper, I've put them in the wrong order. Illegal 0 segment, interesting. Okay. That is why then. Is it? What num? If n got is 0, then we haven't actually got a number. So we'll just do nothing. But also down here, so if n got is 6, then 6, 2 and 3. Oh, yeah, this one. So these two need to be in the other order. We never set can't have 4, so testing can't have 4. Also, when we're marking can't be except, we could mark the ones that are common to 2, 3 and 5 if we have 5 digits, and the ones that are common to 6 and 9 if we have 6 digits. So the ones that are common to 6 and 9 are A, B. Oh, actually, what was 0? 0 is 6 segments. So I forgot 0. Ugh. Well, the 8, 6, 9 and 9, 7, 8. Oh. They're the first 3 digits. It's missing the 4th digit. And 8, 6, 9 is incorrect. That should be 8, 3, 9. So what was the other thing I was saying? Oh yeah, 0 can be returned. 0 is a 6-digit one. So zero is A, B, C, E, F, G. 6 is A, B, D, E, F, G. 9 is A, B, C, D, F, G. So we've got, if we've got C and E, then we've got 0. If we've got D and E, then we've got 6. If we've got C and D, then we've got 9. So if we can have 2 and 3, then we've got 9. If we can have C and E, then we've got 0. 2 and 3 is C and D, which is 9. 2 and 4 is C and E, which is 0. And 3 and 4 is D and E, which is 6. Also, when we're marking can't be except, where is that? If the number we've got is 5, then we need to mark can't be except for A, D and G, which is 0, 3 and 6. And if n got is 6, then mark can't be except. Oh no, this is wrong. we don't want the things that are common to the 5-digit ones. If it's 5 digits, yeah, no, this is right, this is right, this is right. If it's 6 digits, then A, B, F, and G are common, which is 0, 1, 5, and 6, and there are 4 of them. Okay, whoops. Oh yeah, and the other problem was it's dropping the final digit. So on space, when we read a space, we also need to do why is it dropping the final digit? Oh, because on new line we need to do that as well. Well, we know we're on output on new line. And it is new line that resets output, not new num, right? Yes. So, yeah, the first one's wrong. 8694 should be 8394. 9781 is correct. And then a legal 6th segment. Well, it should have been getting a 9. Why does it think there's an illegal 6th segment? For some reason it thinks it can't have 2 or it can't have 3. So when there's an illegal one, let's go actually, let's say so we want to know, we'll first print out which ones we've got, I think. Which is, we can't have I because the input J can't be I. We're trying to fix the illegal, well, the problem in both cases is a 6 segment number, isn't it? Oh no, 3 versus, oh, interesting. It's saying 8694, and it should be 8394, but 3 has a different number of digits to 6. So what blunder have I made there? It shouldn't be able to get confused between numbers that have different numbers of digits, different numbers of segments. So we think the input C can't be any of A, B, D, E, or F. and that's on the third line. A, B, C, D, F, G. C can't be A, B, D, E, or F. So on the third line, oh yeah, A, B, C, D, F, G they're just not in order here, so F, D, C, A, G, B. So why can't C be any of A, B, D, E, or F? Is one. And two is, why are we confused between 3 and 6? 3 has 5 segments and 6 has 6 segments. So I'll look at that one first because that seems like it's likely to be easier. Okay. We've got 2 different places that can return 6 and no places that can return 5. However, this shouldn't be 5. This should be 3. So I might just cross my fingers and move this below the 3. So that should at least fix 8394. So the other case is, why can't C be A, B, D, E, or F? Well, we'll say what mark can't be except is doing. So given what we've got, we know that %D can't be %C can't be %C, which is nums n plus A can't be I plus A. I'm not feeling too bad. I'm an hour and 20 minutes in, but I haven't run out of steam yet. Array index needs close bracket. Eh? Oh. So I don't have copy and paste, so that would be annoying, except for this. Well, okay. CG is so the number 1 has the segments CF. So I don't know why it thinks C can't be F when it sees CG. Because so it's saying when it sees CG, C can't be A, B, D, E, F. this is the wrong way around. It should say I can't be nums n. We're trying to say all the numbers that we haven't got can't be the numbers that we've passed in. Yeah. Okay. Let's try that then. Oh, hello. 1167. That should have been 1197. Well, let's do our why is that taking so long? Because the output isn't buffered and it's going to disk. 8304 is incorrect. That should be 8394. Nine 781 is correct. 1167 is incorrect. It should be 1197. And I don't know the other outputs. Oops. Well, given that we try to return 9 before we try to return 0, the fact that it's saying 8304 instead of 8394 rather suggests that we've made a false assertion that we can't have something. And it must be the this one, because this one is common. So yes, it can't be. The first one is, this is saying can't be, the first one can't be the second one. And how do we know it can't be the second one? Because we said so here. And why did we say so? So let's actually try and work out what's a better way of saying that. So mark all of the numbers that we don't, all the segments that we don't got, that we don't have in got, as unable to be all of the nums, unable to be anything. That seems about right, doesn't it? If we know that we've got a 5-digit number, then we know, if we know that we've got a 5-segment digit, then we know that the segments we have must contain the segments that are used in all of the 5-segment digits, and therefore the segments we don't have cannot be the ones that are used in the 5-segment digits. So this seems like the logic is correct. Let's just check if the numbers are correct. So if n got is 2, then we've got a 1, which is C and F, which is number 2 and 5. Okay, if n got is 4, then we've got a 4, which is B, C, D and F, which is 1, 2, 3 and 5. If n got is 3, then we've got a 7, which uses A, C and F, which is 0, 2 and 5. If n got is 5, then we've either got 2, 3 or 5. 2, 3 and 5 all use A, D and G, which are 0, 3 and 6. And if n got is 6, then we've got 0, 6 or 9, which all use A, B, F and G, which are 0, 1, 5 and 6. And that's what we've got written. We said 5 segments was 2, 3 or 5, and 6 segments is 0, 6 or 9. If we've got all 7 segments, then we learn nothing, don't we? We know we've got an 8, but we don't know which of the segments is which. This should be if we're not on output. That may be the problem. Well, we've had CBD, GEF in the input and CEFDB in the output. So the only difference is that one extra segment is on in a 6 segment versus a 5 segment. So which cases could that be? That could be, well, we know what the number is. It's a 3. So it's A, C, D, F, G. And in the input we would have seen A, B, C, D, F, G. Let's have the output go to a log and then read it. I probably want the slang library to give you buffered I/O by default and make you explicitly request unbuffered I/O, because if you don't care, then it's better to have it fast when it's going to disk. Yeah, so when we see BE, we know that B and E are C and F. So everything except B and E can't be C or F. So agreed, that looks like it's making correct inferences. When we see B, C, D, E, F, G, what do we know? We know it's a six segment digit, and the digits that are common to 6 segment digits are A, B, F, and G. Why aren't we marking F? Is it because we already know all of those can't be F? Okay, and when we get to the end, what's the problem? So the B, C, D, E, F is a digit 3, I believe. And we didn't get any output here because here n got equals 7, digit equals 8. And then this digit equals 3. So a 3 is A, C, D, F, G. And we think we can't have A, C, D, F, and G because B can't be A. Now, why can't B be A? Where have we said B can't be A? B can't be A here, because we've seen a 6-digit input. B can't be A. Oh, okay, fine. B isn't A. B can't be D, F, or G. So we conclude, if we're after A, C, D, F, G, and B can't be A, D, F, or G, B equals C. Okay? Next one. Oh, hang on. We don't need all of them to be able to be the right digit. We just need any of them to be able to be the right digit. The fact that B can't be A doesn't mean we can't have A. It just means B can't be A. So, if not can't be, then can equals 1. So now we say we can have percent %C because input C can be percent %C. Brilliant. Okay. Good. Let's see what that tells us. Was that right? It went too fast for me to see. 1197 is right. Who knows if the rest are right? Ah, okay, the rest aren't right. Well, let's get it in a log file then. I've just noticed a problem there because we'll say things like can have E because input A can be E, and can have G because input A can be G. But if input A is the only one that can be E and the only one that can be G, then we can't have both E and G. However, currently we seem to be failing on thinking we can't have enough numbers, not thinking we can have too many numbers. 8394 correct, 9781 correct, 1197 correct, and then 9391. Okay, so we said 9391, it's actually 9361. Yeah, I feel like this isn't a good way to do this, is it? Well, I'm going to go and have a sit down and a think, and then I might have another look at it. I think we're back. Okay, so the first thing I wanted to look at is what exactly is causing how can we tell that the output should be 9361 rather than 9391? So I'll manually look at the sample and work that out and then see how that maps to our logic. And the other thing was, I worked out that where we call MCBE, that's predicated on output. But it shouldn't be, because the same rules apply whether we're on output or not. So not only does that not want to be predicated on output, but we possibly want to wait until we've read all the way to the end of the line before we try to turn them into digits using what now. But that's more tricky, so we're going to skip that for now and just do that. So now we want to know, how can you tell that it should be 9361 instead of 9391? Back on. So this might just be the fact that we need to read all of the output values to distinguish 9 from 6. So that was the fourth line of the sample input. So we need to distinguish G from B on the fourth line. 1, 2, 3, 4. We should already be able to distinguish B from G because B is present in 7 and G is not. So the problem might be that instead of just saying which digits could we possibly have in isolation, we actually need to solve the mapping of letters to segments, which is annoying. Would it be too slow to depth first search through all the possible mappings? While I had the camera off, I did look at a group chat I'm in and read that some people have been brute forcing the mapping. So obviously some people depth first searched. I wonder if that would be too slow for me. Well, let's just see if the change I just made is enough to make any progress. I'm guessing it won't be. And in fact, I think it ended by saying there was an illegal 5 segment or illegal 6 segment. And the way it works at the moment, I don't see how that's possible. So there's obviously some bug in what I've got at the moment, in addition to the fact that it doesn't solve the mappings properly. Illegal 5 segment, yeah. 8394, 9781, 1197, and it's still saying 9391. So yeah, we probably need to depth first search the mapping is one part, and the other part is, why does it think ABEFG is an illegal 5 segment? So we know that B and C are C and F. We know that BFG are A, C and F. So we know that G equals A. We know that FG, BC and FG. Well, that's an illegal input, isn't it? How can there be BC and FG? Well, yes, I'm not surprised there's an illegal 5 segment, because that's a contradiction as far as I understand it. So is that not the actual input? Does it go BC, BFG, FG? No, it doesn't do that. It goes A, C, B, F, D, G. So what's the problem there? Well, this one ends in CB, which would look like BC, and this is 7 segments, so we wouldn't output anything for it. So I do wonder if we've failed to notice the end line character there or something. Oh. What did the log say? Very curious. Oops, not that. So new line. New num. Okay, yeah, fine. And then we reset got to the start. So at the end of new line we should just print that because we reset there. So there was no contradiction there. Just remember I exited part 2 instead of making a subshell. So if we come to the end, we'd have something like that. So BFG, we know, maps to A, C and F in some order. FG, we know, maps to C and F in some order, which means B equals A, and we can forget this because we already know the rest. we get ABEFG maps to ACDEG or ACDFG or ABDFG. CEFG maps to BCDF. Well, we know B goes to A, so and then ABCEG maps to ACDEG or ACDFG or ABDFG. We know B maps to A. So ACEG is only one different to AEFG, is only one different to CEFG. So they should, let's keep going. ABCDEG and ABC and ABCDFG. ABCDFG also maps to the same things. And we know that B maps to A. Now, how do we solve that? Well, this obviously thought there was no solution because it said illegal 5 segment. Is it the one that's supposed to be 4873? I think it is. And we're looking at BFGEA, which should be a 3. So we know that is a 3, which is A, C, D, F, G. But this thinks it can't have C or F because it doesn't think any of the input characters can be C or F. And it thinks input G can be B, even though we know that G is either C or F. So why does it think input G can be B? Oh, so as well as saying that all the others can't be C or F, we need to say that F and G can only be C or F. Although that still doesn't explain why it thinks there's a contradiction. So as well as mark can't be except, actually for the numbers that we have got, for the segments that we have got, we know they can't be anything that's not in nums. So let's just So if we haven't got a number, and it's in nums, then mark it as can't be. Otherwise, if we have got a number, I think it's just a separate loop. Maybe I'll do it up here. Oh no, this is all wrong. Okay, disregard. We do need a separate function for this. Because we'll have mark must be. So if we've only got 2 inputs, then the segments must be C and F. If we've got 4 inputs, then the segments must be 1, 2, 3, and 5. If we've got 3 inputs, then the segments must be 0, 2, and 5. If we've got 5 inputs, then we don't know. We don't know what they must be. Yeah. So if we have num I, hang on, let's think, what are we trying to do here? Mark must be means all of the numbers in all of the segments in got must be one of the segments named in nums. So if we don't have num j and we've got I, then we know can't be ij. How does this one work? So we'll %c can't be %c because it must be one of the nums. It must be a num. Must be in nums, which I can't be bothered printing out because we should know what it is. So I plus a can't be j plus a because j is not in nums. And we've got an I, so we know I must be in nums. However, this won't solve our contradiction. This will only make us more likely to generate a contradiction. But it might solve us thinking 9361 is 9391. During my little break, Charlie suggested that I should use bit sets rather than arrays of 7 elements. And I think he's probably right. It might be more succinct that way. I've written an infinite loop, haven't I? I don't see the infinite loop, do you? Oh, this needs to be set to 0. Where's the infinite loop? Also, I remembered that I can do this to get some buffering on the output. It's not the best buffering, it's not as good as buff.io, but it will help a little bit, maybe. So I don't think I did write an infinite loop. What's the problem? Oh, that's not good. Okay. Probably I passed a function the wrong number of arguments. Oh, is it printf? Did I... I wonder what's going wrong here. Well, let's just make MMB return straight away and see if that solves it. Because I think that was pretty much all that I added that was new. it's still bad. I think I saw it say output equals. So where does it do that? Ah, haha, it was printf. There we go. So actually we don't want the return 0. Well, it looks like setBuff might have helped because it's spending less time with the storage light on, which means it's doing disk I/O for less time. But it's still not spectacularly fast. Right. Presumably that's the same contradiction it was running into before. So let's just check that. Oops. Yeah. 8394 correct. 9781 correct. 1197 correct. 9391. It's now getting that one correct. Oh no, it's not. That's 9361. We're still not getting that one correct. Oh, that's disappointing. We're still getting stuck on the same case we were getting stuck on before. And we think it should be we think ABEFG should be a 3, don't we? I might try to isolate just this one input. Wow, okay, it gets it right now. Interesting. That means we're not zeroing something from the previous line. What do we do at the end of a line? Ugh. My search and replace is so slow it's almost not worth using. Well, no replace, just search. We reset can't be. Do we reset got? We reset got in this one. What other state is there? Well, when we call new num at the new line, we don't actually want it to do anything, so we can do that. Have num get set to 0 before we use it. Do got and can't be get reset? When does can't be get reset? That should get reset on new line, which it does. And got gets reset in new num. And can have always gets reset before we use it. That's a tricky one. So let me just write down all of my globals. So got is an array of 7. Can't be is an array of 7 sevens. 7 arrays of 7s. Got is an integer. Ch is only used in the thingy on output. Is an integer. Dump got is a function. Have num is an array of 7, but that only gets used in one place, and so we can tick that one. Nums is a parameter to these functions. Answer and output. Well, answer doesn't want resetting. Output is an integer. Can have. Oh no, that also gets reset just before it's used. That's basically a local, but we don't have to free it. Okay. Well, got tells us which segments we've got in the number we've just read. So got should be reset in new num, which it is. So I can tick that. Can't be tells us which segment in the input can't be which segment for real, which means it should get reset every line, which it appears to. The problem is, okay, so I've already fixed it. The problem is that after resetting can't be to 0, we were then calling new num and marking some things as can't be based on the final digit of the previous line. Okay, that's that then. So now let's see if it works. It's turning into a pretty disgusting program, but that's kind of my style anyway. Now hopefully this will do the job. If this doesn't do the job, well, there are two jobs we want it to do. Firstly, solve the contradiction, which I think it will. Secondly, hopefully it will get all the correct numbers on the sample input. If it doesn't, then we need to depth first search and brute force the mapping. If it does, then let's just run it on the input and submit what it says. Okay, so that took 65 seconds on the sample, which is 10 lines. So that's 6.5 seconds per line. So if we were to run that on the real input, we would expect that to take... Oh, I might be able to show off my calculator. Oh no, that was still wrong. Oh. Yes. 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 This one, no. Yes. Yes. No. No. Yes. No. Right. At least it runs to the end now. So the next job is to get rid of most of the spammy debugging and brute force the mapping. That doesn't look good, does it? That looks like it might be searching past the end. That looks like it was searching through all of memory past the end of a string. So my control F has a bug in it. Okay. Well, I'll write that down then. Control F bug. The reason I can tell it's searching through all of memory is I can see that the values in the registers are going up really high. So I guess I manually search for printf calls to comment out, and dump got calls as well. Output I still want, I think. But I don't want these ones. I don't want that either. Okay. The answer, what was it, 200 lines, and they're all 4 digits. So the answer will overflow a big int on the real one. So we may as well switch that to a big int now. Okay, and we need to depth first search the mapping of segments. So what's the easiest way to write that, given what we already have? I think we don't want this anymore. Oh no, we still need to know well, what we want to do is make can't be NM should be true for 6 M's for each N. Okay, so meaning each N can be exactly 1 segment. Now the thing about I wonder if the digits on the left-hand side of the pipe character always are enough to determine the mapping. For now, let us assume that they are. So as soon as we see a pipe character, we want to compute mapping. So how does compute mapping work? we'll have a depth first search which wants to know which characters have already been... Oh no, I'm running out of disk space. My video is too long. Cock. What am I going to do? Maybe I'll delete some of the previous day's videos. So let's get out of screen. Well, the 2020 ones, let's get rid of. How big are they? Yeah, that'll be good. And then redraw. Okay. Right, what's our DFS going to do? Depth first search needs to say for each which digit it's working on, which segment it's working on, and which segments have already, which input letter segment and which output segments have already been used. So actually used, we'll just make it global. If input seg is 7, then we're done. Otherwise, what I'm going to do is we'll have a second thing like can have. No, we'll just overwrite can't be. We'll just solve this and then overwrite can't be. So, while I is not equal to 7, don't forget your I plus plus. If we haven't yet used the ith segment, then let's say the input seg must be I and not can't be input seg I. Then let's say it must be by remembering what we previously thought it couldn't be. This would be so much easier if I did the bit sets thing. Am I really going to malloc inside here? Once per line. Sorry, we'll malloc inside here. Must remember to free it. So we'll copy to old can't be input seg 7. We'll set can't be input seg to 0 for everything, and then we'll say, sorry, we'll say it can't, we'll set it to 1 for everything, and then we'll say it is I, and then recurse. So if the next level is happy, then all we need to do is free old can't be and return 1. We need to mark this number as used as well. Otherwise, we need to undo what we just did. So used I equals 0, then copy to can't be input seg from old can't be 7. And then at the end, we didn't reach a solution, so we need to return 0. and then we'll assume that this works. No solution. And let's see if that does it. Given that we're brute forcing the mapping, there is obviously going to be a nicer way to work out which number is which, but it's all about reducing the amount of work I have to do. Yeah, 9361. It said 4648 though. That's wrong. Well, at least we're getting a bit further. Let's see, 8394, 9781, 1197, 9361 is now solved. 4873, 8418. That should be 4548. So why would we say it's 4648? Okay, on what else did it say? (1626). How can that be 1626? Should be 1625. Eh? How can that be 1626? It doesn't even have the right number of digits. Lol. Given that the output began halfway through what the kernel should say there, I don't think we're going to trust the state of the kernel here, so I'm going to reset it. Wow. Maybe we put some of the debugging prints back in. Interesting. Why is it working now? What was going on there? I wonder if the computer's been running too long and it's getting hot, and something's not working properly anymore. So previously I had a problem where I left it running for 6 hours or something, and it ran fine for 6 hours, and then just spuriously started executing nonsense. So that may have happened there. What we'll say is that there's no bug in the program, and we'll press on. So how can that output be 1626? So actually the behavior we've observed could easily be explained if it just always prints a 6 when it should print a 5. Because all three that it's got wrong are printing a 6 instead of a 5. let's see if I accidentally wrote a 6 where I should have written a 5. Yes, I did. Great work, Jess. Well done. Also, why it only sometimes gives us dump got, I'm not sure. Oh, because 2437. Yeah, okay, great. Well, that might be the end then. That might be the answer. Ha. I thought I checked all of those numbers. Oh, the problem is that I wrote the wrong thing down on my paper. Good. Now, what did problem 2 say the answer was for the sample? Is it 61229? Yes, finally getting somewhere. Let's see what this says. So there are 200 of these. We're doing about 1 a second. Maybe 2 a second. So it'll take about a minute and a half. I'm sure it could be made much better. Once the DFS function has computed the mapping, like the DFS function decides what the mapping is, then expresses the mapping in terms of what input segments can't be what output segments, and then what num looks at what input segments can be what output segments and then decides what it can be. So it feels like there's a whole round trip through the can't be array, which is just unnecessary. It's possible that we still don't have the right answer in the event that there is more than one way to map what we have, to map the segments, because our DFS stops at the first one, it finds. But if there's more than one possibility, then we won't realize. It's not obvious to me whether there would be able to be more than one possibility or not. Yes! Finally got there. Well, that one was actually quite fun. It took a long time though, and I don't think I did a spectacular, well, I think I did a shocking job of the program, but it was more fun than I found the other ones that took me a similar amount of time. Do you know what? I don't think I can be bothered tidying up the program. Yeah, well, there we have it. Great success. See you later.